So quick disclaimer, this is still private, so I would appreciate if no one takes a picture and tweets about it. But it'll all be very public, honestly, midweek, and then we're actually going to start doing this in 2 weeks. I don't know how Drake keeps on inviting me and I keep on telling private things. I did this back in November with Boundless in general. Who am I? I'm Jacob. I'm the product lead for Boundless. I work at Risk Zero. Boundless is sort of the evolution that we see Risk Zero heading. Boundless is this. The big takeaway, I'm not going to go into details, even though there's a lot of cool things. You can think of the Risk Zero ZK VM as a ZK computer, right? It's literally a ZK circuit that looks like a CPU. This is ZK AWS, so you should be able to show up, request a proof, and just get your proof. So on-demand compute for your ZK applications. We're actually already live on base and everything, and it's like fully decentralized, permissionless. Anyone could come and prove. Takes like 30 minutes to set up a prover for 100 GPUs, which is pretty cool. And now that we're live on base, it's time to stress test a market, right? If we have a market, we need to test these dynamics within a market with real money. You cannot have someone show up to a website and click a button on a screen to send test transactions. That's not going to work for us. So we sort of started asking ourselves, how could we push this system and solve an open problem and use like all of this energy that our community has and point it to a public good. And that's where we're sort of going with the signal. Additionally, if you see a lot of berries on your timeline, that's us. Yeah. And this is the problem we wanted to attack that, all of y'all are going to be, very familiar with, right? It's very hard to talk to Ethereum and have it in a trustless way unless you're running a full node. This has caused, an historical reliance on, either trusting an RPC provider, trusting a multi-sig, or a set of oracles to rely this information on you if you're not running a full node. There have been some really great attempts at this. So you have Helios, which I know is like a execution consensus client hybrid thing that validates that the sync committee is operating properly. Same with Polyhedra has tried this as well, and I think Drake mentioned what Sync had done a few years ago. But these have weak economic securities. I think if you want to talk about Altair-like clients, James Presswich has done a bunch of work around that. But we're on this insane trajectory of ZK. I think you would be surprised how our internal Slack reacts to performance. Sometimes we get a number and we're like, that can't be true. We have to go rerun it and whatnot. So recently we released V2 of the Risk Zero VM. It's like a 5x improvement. And additionally, we're about to release V3 and a new orchestration system that we should get a really nice bump. The Boundless market comes with a really nice bump in cost and whatnot. We're moving from charging people from on-demand AWS cost to on-prem people where governments are subsidizing energy, so it makes it really expensive or cheap. And then also we have this new thing called proof verifiable work where we can sort of now understand how much work a prover has actually done when generating proof and retroactively give them an incentive to bootstrap this market. And then lastly, and this is probably the most important one with doing this full SNARKification of the beam chain, is Impectra EIP 7549 reduced the cost of validating attestations by 100x for us. So we looked doing this a few months ago. No chance. One of our engineers hey, this EIP got included in Impectra. And we clicked the button, ran the program. It's oh my god, it works now. Which really do. So if you worked on that, big thank you. And here's our answer. So we've developed what we call a zCasper, where we generate a full validity proof of the Casper finality gadget, verifying that a checkpoint has been finalized by the validator set. And what is sort of the result is we get this verified.
I can use ChatGPT to answer that. You can enable ChatGPT on your Mac.
And that's what I get for Apple not being very good at AI. The result of this is that we get this verifiable block cache that can be used to compute over or against Ethereum's most recent finalized state. So the TLDR here is we're sticking the Casper finality gadget along with a bunch of edge cases that I'm sure the consensus teams are aware of here inside the ZK VM. And it's actually not that bad. So when we generate this proof, it's about 40 billion RISC-V cycles. So this is a per epoch thing. In comparison, a EVM, don't tweet it, Okay. Pictures are fine, but yeah, again. Which is, in comparison to an ETH block is not bad. ETH block is like 300 to 500 million RISC-V cycles. I know there's some people that are also doing like a Beacon STF, and it's about 5 billion cycles, but really not bad. What does latency look like here? Of course, we have to wait for a block to be finalized, which is 12 minutes. And then it's only 6 to 8 minutes to generate the proof. These numbers I'm showing here are very conservative. These are on our old V2 and orchestration system. So these are sort of similar numbers what we were quoting for real-time proving, but maybe y'all have seen Jeremy talk about how we can keep up with the executor with much less machines. Essentially, we found a way to stick 3 proving agents on a single 5090 because we don't take up that much memory when proving. So you could see that number from 100 4090s go down to only needing 16 5090s with their new orchestration stuff. And then V3 again should be another bump. So pricing is $80 is a very conservative number here, just because it's hard to price things. But less than $80 per epoch on demand AWS pricing. If we go back to using the boundless market, which is where we'll be generating these proofs, we currently use an instance in AWS that's like $1.80. I'm getting quotes from like GPU providers, like 20 cents for the same GPU. I don't know how they're getting these costs, but I'll gladly take them. And then clearly they're still making money on me. So, right, so there has to be a 30-40% bump there, so it's even cheaper. And then the bottlenecks, you see I couldn't pull up a profile, unfortunately I couldn't generate on my laptop because it takes too long to execute. But it's 30% of the proving time is BLS, and then about 3% is SHA-2. And then just a reminder, right, as we move to like more hash-based signature schemes, BLS is much more expensive than hashing. I don't know a number off the top of my head, but it's at least a magnitude more expensive. And then one really cool thing about this is we have this library called Steel, and now that we have this like sort of checkpoint block hash, we sort of like can run Solidity inside the ZK VM now, and check this block hash, and then compute against that state. And the cool thing with Steel is, right, you can actually go backwards. So if you use that checkpointed state, you could sort of query what's happened in that epoch. You can do a range of blocks all the way back to Denkun, and you can actually query for events as well. And it doesn't stop as Ethereum. We were calling this the signal genesis because we want to prove more things, and we think with proof of verify will work in the boundless market, we can just start to do so. I think something you're going to see in a few weeks, right? We're going to be doing Zcasper, but why not just turn some rollups into ZK rollups? You can sort of do this without their permission, which is interesting as long as you assume the sequencer doesn't rug you. And this really starts to deliver on some of the interop we're seeing. And what I really like about this approach versus maybe some standards that are going out, or like, you take something like the AG layer where you have to like opt into their standard, is this just retrofits what already exists out there. And it's possible to do. And it's not that expensive. This is a number for our like ZK stack that could turn base into a ZK rollup. This was in March. So I assume the number is only lower. This is sort of an annoying number, but right, so per block for base, we're at like 1 cent, which is not bad at all. And then when we really think about like, this is a lot, and I'm not gonna go into the details, but I'll sort of explain the idea here, is as we start to prove more and more chains, like Ethereum, you now enable trustless outbound messages, as Ethereum. You can sort of think of it as like gateways in the internet. And then let's say we start to like prove base or Arbitrum or OP mainnet. If we prove just base and Ethereum L1, now if you post the block hash of Ethereum L1, any other L2 can trustlessly just query what's happening on base because of a world of proof of proofs, which is really interesting. You no longer have to pay for these multi-sigs and messaging protocols to charge you a fee. You're literally just going to query a block hash that's already existing on the chain you want to operate on. We do think this is like a really, really strong foundation for future interoperability. Some of the use cases that we're already seeing come out of this are quite interesting. Boring one, it costs less, right? Like if you go to Wormhole or Layer 0, right, these like multi-sigs are charging you money. We're going to run this as a public good. And we're actually already talking to these bridging providers to integrate it instead of using this reliance on multi-sigs. I think another really cool one, I am personally a fan of the idea that there will be a lot of L2s not just like the 3 or 4 that have activity today, but maybe 1,000. And one big problem with launching L2 nowadays is like, okay, DA, already kind of cheap. Yes, we should have more blobs. I can go to Conduit or someone, pay them like $1,000 a month to spin up a roll-up stack for me. It's not very hard. But the integrations are really, really expensive. So if I want CCTP, which is a really key tool to bring large amounts of liquidity, I'm going to need to pay Circle $2 million. If I want to integrate with Chainlink, rumors are it's like 250 to 500K. Layer 0 can be around that amount. No so safe. Now if I can trustlessly query Ethereum state, I now gain access to all of those integrations. So I could just query this proof, and I'm bringing Chainlink to my chain. I'm bringing, you could do a CCTP wrapper, which would require a little bit more. I'm bringing CCTP, I'm bringing Gnosis-Safe, I'm bringing ENS, and we're just reducing those barriers of entry to L2s even farther. One little bonus thing we're going to do as well is we're going to pair these consensus proofs with execution proofs. So not only can you validate that this is the state that the validator set has accepted, but you can also validate, anyone, that they're acting honestly. And we're actually going to have this running on a website in a few weeks, to where you can just show up, click a button, and you're now verifying and sort of contributing to the civil resistance of the network that the validator set is acting honestly without running a full node. So if you're a really security conscious user of like MetaMask before sending a transaction to the chain, like make sure that they're not wrecking you, which I think is pretty cool. Again, why does this matter? Let's reduce cost. Let's reduce trust. And then additionally, we always want to be technically innovating on sort of the interrupt story. And then what we're going to commit to here is it's going to be fully working for anyone to use. We're going to maintain it, run it, make sure it's audited, make sure it's open to the rest of the spec. And then we're also going to do quite a bit of subsidization. You can think of that proof of verifiable work as an incentive to bootstrap adoption and demand, and this is going to be the first thing we're going to throw at it. Just 2 more key takeaways going through this journey. Well, I guess we're moving on. Ethereum, by far the most CK friendly chain, so thank you for that. We've looked at other chains like Solana, not really possible. They need to change a lot of things at the protocol level. Last thing, and I think the word's starting to get around here, is the speed of improvement on ZKVMs. There's just so many great teams working on it. One example is like Airbender, if you guys saw the announcement last week. Bonkers numbers. We're going to learn lessons from there. And really just there's so many great people. I would expect another 10x just in software by the end of the year, between known things we know we can do. And then the last thing is you can sort of just do things. We're going to take this full Casper ZK thing from idea to production in less than 3 months, which is pretty cool. That is no thanks to all of the consensus client. We have taken a lot of code from some consensus clients, and also some of the guarantees we've gotten around the form verification work has been really fantastic. Yeah, and then we're really excited. I know that EF's going to help us. We're working with a lot of other people, and a bunch of L2s and bridge providers are really excited about this as well, which we're excited to work with. And yeah, that's it. Go ahead.
I have a question about the attack vector you mentioned. Can you explain how that would work? Like, why do people have to go to a website and verify a proof from the execution and the consensus to be assured that the system is sound?
Yeah, so I believe Vitalik was on a podcast like a month ago talking about this, and I wasn't really aware. But the idea is that the validator itself could, cooperate together and fork an invalid chain and steal funds or whatnot without you knowing if you're just checking a consensus proof. So they could do an invalid state transition function or whatnot. So this way you at least check both, and then are aware of if they're doing this. Any other questions? Sweet, thank you guys.